Hello everyone, today we're going to be looking at special right triangles. Special right triangles. And the first triangle we're looking at is a 45 degree, 90 degree triangle. And so what I want you to do is take a look at this figure and copy this down somewhere. You need to have this. Special right triangles are about the most heavily covered topic you will see on the SAT in regard to geometry. So take these lessons seriously, please. So we have two angles here that are the same, and these are our base angles of our triangle. And that means that this is an isosceles triangle. So because these two base angles are congruent, we know that these two legs will be the same. And that means that whatever this side will be, let's just say that number is x, then whatever this side will be, x, this will also be the same, right? So some number, just call it x. And what is special about this triangle is what we find is that no matter what the value of x is, the hypotenuse, which is right across from our value for x, so right across here, it will be whatever the value for x is times the number square root 2. So this will be times the number square root of 2. This is actually because of the Pythagorean Theorem. Hopefully you saw that in a do now activity. So we have our legs. This is both of our legs is the number x, whatever that number is. And then the hypotenuse will be that same number x times the square root of 2. Over here I'm just going to write it again, just so we can see. So we have our value for x, this is the measure, and then our hypotenuse will be x times square root of 2. And again, please write this down somewhere, take some notes on this, because we will be using this form a lot. And in fact, on the SAT, you are given this figure. You are given this figure, and hopefully when we go through this next example, we will see how useful this figure is. So I'm just zooming in here. I'm looking at which one of these sides is my hypotenuse. So here's my right angle. I'm going across. So I know this is my hypotenuse. And that means that these two sides are the legs. These two angles are 45. So that means these two legs are the same length. So we know that the value for x is 8, right? So we know this value x, I'm actually just going to cross this out now and just write 8 here. Okay, well, if x is 8, then what is the hypotenuse? Y. So if x is 8, the hypotenuse, well, x was the number 8. Let me just get rid of this y. X was the number 8. And we are multiplying whatever the leg value for the leg is by square root of 2. And so don't overcomplicate this. We don't need a decimal value for this. We don't need any sort of thing like that. This is the number. This is an exact number. It's not an approximation. Oftentimes when we see these, we will use this. You will see this as an answer. And this is what we want, especially on a standardized test. We want this square root of 2 to be in our answer because the figure we're working off of uses that property, uses this property. So whatever the measure of this segment is, that means that whatever the measure of the leg is, the hypotenuse will be that measure times the square root of 2. So simply, here we saw the measure of the leg was 8. What's the measure of the hypotenuse? Well, it's 8 times square root of 2. And so our answers here, x was 8, and the hypotenuse was 8 times square root of 2. So, very similar. Coming over here, and I'm looking, okay, here's my hypotenuse. I'm just going to get rid of this x here, and I'm just going to write hypotenuse. And that means that this is my leg. So I got these two legs here. We have our 45 degree angles. Let me get rid of this y. So we know that if our one leg is 25, the other leg has to be 25. The other leg has to be 25. And our hypotenuse will be the measure of the leg, which is 25 times the square root of 2. And some of you might be thinking, Mr. Hissner, there has to be more to it than that. There's not. When you're given the leg measure, you are simply using this property. It is a property of special right triangles. It's why they're so special. It's why they're so special, and we hold them dear to our hearts. So x was our hypotenuse here, so this was 25 square roots 2, and this was just 25. Okay, take a second and think about looking at this problem number 3. What's different about this problem than the last two? Hopefully you're realizing that we were given here the hypotenuse. Given the hypotenuse. Well, if we were given the leg and we multiplied, but to get the square root of 2, see, notice how this leg is smaller than the hypotenuse. So multiplication is making this number bigger, right? If multiplication is making the number bigger, then if we have the hypotenuse, so now we have the large side, what's the opposite of multiplication that makes things smaller? What's the opposite of multiplication that makes things smaller? Hopefully you're realizing that is division. So here, to go from the hypotenuse to the leg, we're going to have to divide 19 by the square root of 2 because we're making it smaller. Some of you might realize that this is mathematically illegal. You're not allowed to leave problems like this. What you must do is either use one of your fancy calculators that just gives you the answer right away, or just do old-fashioned mathematics. I'm just going to multiply this number by a special 1. Square root of 2 divided by square root of 2 is just the number 1. Something over itself is 1. Anything times 1 is itself. So this multiplying by this value does not change this value. Multiplying root 2 over root 2 does not change this value. So whenever we multiply fractions, we just go straight across. This is 19 root 2 over, well, what is square root of 2 times square root of 2? Well, this would be square root of 2 squared, and we know squares and square roots cancel, and so what we need is just the value in here. And so that is actually just going to be 2. And this is a pattern you will find very often. Whenever you divide by a radical, what you're going to do is multiply the top, and then the bottom will be freed. You'll just free whatever bottom number that is. So our x value here is the same as the y value, and this is both the 19, oops, let me give some space, 19 square root of 2 over 2, 19 square root of 2 over 2.